Broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. My name is Benoit Mallol. I'm the head of the Marine Department here at NUMECA and also the product manager of the Fine Marine Software. It's my pleasure this morning to present you this webinar on the C Wizard, which is belonging to the Fine Marine Software, and the cloud offer that NUMECA is proposing since last year now. So this webinar will last for approximately 30 minutes, and afterwards you will be able to ask any question you may have on this webinar, of course. So I'm going to start this presentation by explaining what is the cloud offer that we are proposing here, which is called the NUMECA Cloud Power HPC. What is it about? It's a cloud offer, so it means that there are some machines available for you to make simulation of CFD. It contains the latest cloud technology. We believe it's a user-friendly access and use. It's accessible from any web browser, so it means from all platforms, desktop, laptops, tablets, even mobiles. There is absolutely no hardware or software installation. It contains a high security infrastructure and is always ready to run. So what is very specific to this offer is the container. A container is incorporating CPU, GPU nodes, which are multiple of 24 cores, a desktop, of course, to access the graphical user interface, all the software, all the NUMECA software, and some storage for all the data that you are going to generate. This container can be connected to a fixed IP address or VPN belonging to your company. This container is powered in collaboration with UberCloud, which is our partner for this offer in the cloud. This container is, at least we believe that it has the right size infrastructure. It's a very fast to generate and to ship it to you. You always have the control about what is happening because it's a desktop, it's a virtual desktop, so you can control everything you are doing over there. And of course, it enables any new use for any cases that you want to perform with NUMECA software. The flexibility with this container is the following. It's ready to execute for installation, which are already done, of course. The software are ready to use, license is already on, etc. There is no need to deal with complex operating system commands or installation or configuration and so on. Everything is already done. The software is configured. It is tested as well, so we know it very well. It's running on bare metal and there is no loss of performance, which is also very important. And cherry on the cake, I would say, is shareable with NUMECA support, because if you want some help, we can directly have a look ourselves to see what's happening. And that's also, for me, a key advantage running on the cloud. So where is the cloud? And here I'm not talking about the weather forecast, but really of the cloud of the machine which are going to be available for you. It can be either at NUMECA, either with our partner of CPU 24/7 and at Vania, or as well with all our partners, which are Microsoft Azure and Amazon Web Services, which are also available all around the world. So what we are going to do is to prepare the container, and as soon as this container is ready, we ship it to the infrastructure that you would like to run on. It could be definitely NUMECA or any others, which are mentioned on these two slides. So what is the workflow for this access to the cloud? First of all, you have to make a request. Then you have to make a payment according to what you want to book in the cloud. We are going to verify that, approve it. That's the second step. And as soon as it's done, we are going to deliver the container by email. Then the user is ready to start. He can perform all his simulation. That's step 3. And as soon as it's over, we go to step 4, and the user has 48 hours to retrieve the data. As soon as everything is ready, we wait for the user approval to close, and we stop the container. So the container will no longer be available at all, and the data will be deleted. So how to request an access? That was the step 1. First, you can contact your local provider. That's the easiest way to do it right now. In a very short time, we're going to provide an online registration. So we will receive all the information that we need to ask you to be able to book this container or to prepare the container for you. And the second step was that you are going to receive an email. This email is shown here on the screen, and I'm going just to make a demo of what will happen as soon as you receive the email. So you receive the email with the configuration that you have selected. You have a password, of course, a login step. You click on the login button. And here you are going to put the password, click on connect, and you're done. So the container is ready. You can type the command to launch FileMarine, for instance, and the simulation, or let's say the interface, will start immediately. So if I restart again this video, I just wanted to make a pause on the email which is sent. So here we are telling you which software is ready to be used, the number of nodes, the name of the nodes, how to log in, a brief introduction about how to access this environment here, if you still need an information about it, and the way to transfer the data. So we have 2 ways to transfer the data. The first one is Dropbox. If you have a Dropbox account, you can use it, and over there you will be able to connect to it and transfer the data directly from that. Or if you prefer something a bit more secure, you can always use an SCP or SSH protocol, which will allow you to make this connection in a much more secure way. So this is very important because it will explain you what should be done to transfer the data in a very efficient way. So the main question now is, who has access to this cloud? The first possibility is you already have, or you already hire a client of NUMECA. You already have a valid license on site, on your site, with an annual contract or under a maintenance contract. So it means that you bought already a perpetual license of NUMECA. At this moment, you can always request the access. Or you don't have at all a license on site, but you want an annual license only on the cloud. This is what we call the NUMECA Cloud Power by the year. And for the whole year, you can have the software license, the container, and the CPU hours, which are all packaged together. The last possibility is you are not valid, or you don't have a valid license on site, or you don't have at all a license which is under a maintenance contract, and you didn't buy yet the Cloud Power by the year. Sorry. So for this, you can become actually what we call a Cloud Power member, and it will allow you just to book from time to time a container. So not for the full year, but just from time to time. For this, you will have an annual entry fee of 2,000 € per year, and it will allow you to access or to request the access for the cloud anytime you want for the year. So that's the 3 categories of person that you can be to be able to request an access. Interesting enough, this offer has been launched end of 2016, and already in 2017 we had several customers who use that in the turbo machinery, in the automotive industry, and so on. But just focusing on the marine customer, this non-exhaustive list will just show you who has already requested the access and used the cloud successfully. So what about the C Wizard? Because the purpose of this webinar was to see how to combine them together to make the most efficient use of the FileMarine software. The C Wizard is the following. It's a complete automated setup for the mesh generation and the computation. It is the goal of this wizard is to, of course, to avoid any potential errors from the user, to increase the productivity because everything is automated for this setup. And something also very important that I always like to highlight is that it's developed by users, tested by users, and of course made for users. The reason why I'm insisting on that is this C Wizard is developed in the Marine team inside the application engineer team. So they are discussing with you all day long. They are refining the guidelines in the manual, they are making support, they are making documentation, publication, so they know very well what FileMarine needs to be able to make a complete automation of the setup. So that's why this wizard is very user-friendly. It talks to the marine engineers and to naval architect because we try to use the same vocabulary. And of course, it's bulletproof since it has been done for many years already. It's incorporating several applications, 7 to be exact. The first one is called resistance. So we are just solving the trementing, for instance, for a given speed for a resistance curve, for instance. The second application is called sekeeping. Just mean that we are inserting some waves inside the simulation. The third one is called open water, because we can do the propeller alone here just to quantify the propeller performances in open water condition. The fourth one is called planning regime. This one is dedicated to resistance, but it has something in particular, which is the fact that we are going to use Savitsky prediction or a user-defined prediction for high-speed boat. The reason why we differentiate that from resistance, because from resistance we think that it's more for tankers, for containers, for sailing boats which are under a Froude number of 0.4, whereas for planning regime we go much higher, and for this one we apply different techniques for meshing, for solving the equation during the simulation, and so on. The fifth one is called sailing yacht VPP. It's dedicated to sailing yacht matrices of simulation. The next one is called hydrofoil VPP, because we are making only foil simulation, isolated foil simulation for matrices or as well as simulation. And the last one is called trim optimization. For this one, we are going to try to find an optimum trim, an optimum static trim for the later use of the ship during the cruise of the ship. So we are defining different trim at the port so that we find the best dynamic trim during the simulation or during the cruise. So this one is also done thanks to the C Wizard. Why we have two different blue colors on the screen is because the first part are available through the graphical user interface or in batch mode. The second one, second color, the light blue color, is only available in batch mode because they are dedicated to matrix of simulation. Most of the people are doing many simulations, maybe tens or hundreds of simulations for these configurations. And so we believe that it was not necessary to interface that directly in the GUI because anyway, we are going to generate many projects, many simulation, many files, and so we have to start to work batch. Another information on this application is that for the resistance, sekeeping, planning regime, or trim optimization, you can either impose the speed or make a self-propulsion simulation. So I mean solving the speed. And you can do that thanks to the actuator disk model. Concerning the graphical user interface that I'm showing on the left side, This interface is quite handy or user-friendly because it is going to ask you very clear questions about please create a project, please choose your application, please choose the units, please choose the speed, etc., etc. Only questions which are dedicated to the physics. And as soon as ready, you click next, 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 and start. There is a difference with the batch mode. The batch mode is, of course, in batch, so we never open the FineMarine interface. And we are going to answer all the questions from the graphical user interface directly inside the input file. So I've shown here just a part of one of the template file that we provide. All the questions, of course, or all the inputs which are necessary are already pre-filled, but you can, of course, change them. For instance, to give the name of the project that you want, or to give the list of dots that you're going to impose, or the path to the geometry file, etc., etc. So at the end, this template file will summarize all the questions which are being requested inside the graphical user interface. So it's very important to understand that there is absolutely no difficulty to work with template file because they are exactly the same as the one from the graphical user interface. And there is something in addition which is provided inside the batch mode is what we call the matrix mode. It's represented here because here we can define many dots, many trim angle, and many other values which are dedicated for a matrix of simulation. Why do we differentiate matrix from the standard simulation? It is because, for instance, if we decide to go for a matrix of simulation with many different angles or many different dots, speed, and so on, we can decide to create one project per dot, for instance. One project per speed is your decision. And why you have to make this decision is because for a given dot, maybe you will need to remesh compared to another one. The mesh generation will be performed as soon as we start, of course, the wizard. And if you realize that you cannot consider many dots for with the same mesh, then you will need to make another one. And so you will need a different project file. And so this is why we need the matrix mode. Now let's go for practical examples. The first one is a resistance application. So I put myself in the place of a user who wants to order some clouds for NUMECA. So I want to perform a resistance curve with 5 speeds and 2 loading conditions. The geometry is quite simple. It's a container ship, barrel. And the first task that I need to do is to estimate how much should I book from for the container so that I can pay the right price for my simulation. So I can estimate such a mesh at 1.5 million cells. The first simulation for the first speed will take around 2 hours on 24 cores. And the next successive restart, so we start from the first speed V0, but then I will restart to be able to start V1, V2, V3, and V4. They will only take 1 hour because I start from already pre-converged speed already. So it will take less time. So my idea now will be to book 2 nodes with 24 cores each to run the 2 loading conditions at the same time because I want a very fast turnaround time. So at the end, it will ask me for 6 hours in total. I will say the 6 hours during the day. And I will run 10 simulations on 2 nodes, which means that I'm going to use 12 hours of CPU. And this is important to convert into CPU hours because this is the base of the calculation of the price. So now I go for the cost estimation. If the price is 0.99 euro per CPU hours, this simulation will cost me 570 euros. So it's very clear, and this is something you can easily understand and easily propose to your customer. Knowing this, I can prepare my matrix mode, because here I'm going to make 2 drawouts and 5 speeds. I take again the template file. I have defined, of course, here the name of the project, here the number of droughts, so the 2 loading conditions. Here I have defined my geometry of the container. Here I have defined my list of speeds that I want to perform. And I'm ready to launch the simulation. Of course, I need to check that water properties are correct, that I don't need to activate actuator disk, etc., etc. There are a couple of questions extra, but that's the main important answer that I have given to the template here. As soon as this is ready, I can upload the geometry and the C Wizard input files. And as soon as this is done, I go to the container and I type the following command: filemarine62 -print to get the information about what's happening, -batch to say that I'm the one to open the GUI, -C Wizard to say that I am in the C Wizard mode, and the input file that I just filled in, which is -input and this file here. Immediately, the C Wizard will create the project structure, and followed by running the simulation, the mesh generation. So the project structure is the following: it will create 2 projects, because there are 2 loading conditions. And for each project, it's going to calculate or to propose 5 computations per project for the 5 speeds. Why we don't need to create a different project for another speed is because we are going to take the highest speed that you ask for inside the speed list, and we are going to compute the number of viscous layers based on this information. The speed is only interesting for us in terms of calculation of the viscous layer, and we need to be sure that taking the maximum speed, we will cover the full range of all the other speeds which are inside the simulation that you ask for. So that's the reason why we can create only 2 projects, and each project will contain 5 computations. When this is done, I will have to launch all the calculation myself, and I will need to perform, if I want, because I could stop there and retrieve all the data. I can perform the convergence analysis just to check that everything is okay, check the convergence for the drag, for the trim, for the sync, and so on. And when this is done and it's okay, I can download everything for later analysis. For instance, to make pictures, to make animations, to make a particular investigation on the wave pattern, on the pressure on the bow, whatever you want. And most of the time, what we have seen from our users, that they are downloading all the data immediately, that they don't spend time or CPU hours doing this post-processing manually. There is something I wanted to insist on for remark for the point 3 and 4, is that for FileMarine, everything is scriptable. So using the C Wizard, you will use, or you will automate the first part of the process, which is the mesh generation and the computation setup. But the C Wizard will not launch the simulation for you or make the convergence analysis or the pictures and so on. So this is why it's very important to remember that everything is scriptable that you can do on your site, which could ease the launching process or any post-processing. An example is the convergence analysis. Inside FileMarine, we have a tool which is called the result analysis menu or tool. And this result analysis can be totally scriptable. So you can just call one macro command, and this macro command will ask you, okay, what is the output that you want to investigate or to check? And you are going to run this macro for all the computation that you have done. And this macro will tell you immediately if the computation is converged and what is the average value, what is the I don't know, self-propulsion coefficient, etc. We have many ways to investigate the convergence of or just the results from the raw data from the simulation. Also, of course, the post-processing with the picture, animation, and so on can also be automated as well. But it maybe is taking too much time compared to what you would like to do, and you could do on your site if you have the license, of course, on site. What we want to do now, and that's just for a short-term future, we are going to propose this kind of script for launching simulation, for the convergence analysis, and so on, so that you can just take them and use them or tune them. It will be just open scripts, of course, that you will be able to use to automate the process as well. And the idea will be to provide that first in the package, but also on the container. So you will be able to launch hundreds of simulations just in very limited amount of time. On this point, I would like to add a last comment is, please always contact NUMECA if you have anything to do on scripting and so on, because we have a lot of experience, we have a lot of tools internally, and we are ready to share anything if you want some help on this subject. Here is a second example. Now I want to perform a maneuvering simulation. This maneuvering simulation is about a zigzag simulation for a high-speed boat, including appendages. So here there is absolutely no symmetry of the configuration, and I need to perform the both sides, and it will take quite some time because it's an steady simulation. I cannot estimate such a match at 10 million cells. The simulation for only one speed will take around 2 days on 72 cores. So what I need to do now is to book 3 nodes with 24 cores each. And I know that the simulation will then take 48 hours times 72 cores, because 48 hours is 2 days, which is equal to 3,400 hours of CPU. So now, when we contact NUMECA, NUMECA will immediately propose me to book 4,000 CPU hours, because we have some blocks of CPU hours of 2,000 that can be booked, for instance. And this 4,000 CPU hours will come at a price of 1,920 euros, or a cost for the CPU hour of 0.479 euros. So compared to the previous price, it's already divided by 2. So my message here is that the more, of course, you buy of CPU hours, the less the price will be. And that's very important, of course. So this is important to remember, that the price will depend on the number of CPU hours that you want to book and the duration. Okay, so now if I switch to the conclusions, the access to the cloud for NUMECA is very easy and fast through the web, through a web browser, sorry, and wherever you are in the world, even if you are in New Zealand, or if you are in Hawaii, or if you are in San Francisco, or wherever, it doesn't really matter, because we always find the closest cloud for you to be able to run the simulation and to have the fastest web transfer that you can imagine. The second point is that the access is completely secured. And I would like to insist on that, because we regularly have the question, is it really secured or not? Nobody can see your files. Nobody. It's totally secured, and is just belonging to you. Also including the password generation, because this password creation, the user creation, the password creation is fully automated, so nobody can see it. So it's just let's call it a script or robot which is sending the email, and nobody has seen that. However, you can always give this information to the NUMECA support team if you want, because then we can log in on your session and see what is happening. If you want some help about making a simulation, or if you want some help for the post-processing, or start a C Wizard, whatever, we can always have access, only if you decide to have it shared with us. An important point is how to estimate the time and the cost, of course, for booking the hours on the cloud. So I will say that you can always request some help from your account manager to estimate all this information, because we know it's very important for you, but also for your customers to know exactly what you will need in terms of CPU hours. So this is something that you can always ask, and we are of course very happy to help you for estimating this kind of simulation. The price for the hardware and the software are all included, so there is nothing extra compared to what I already explained. And we believe that the pricing is highly competitive compared to all the one from the competition. The combination of the C Wizard with the cloud is also a key advantage for any company size. And I already insist on that for two reasons. The first one is because of the nice automation from the C Wizard. We have seen that it's applicable to resistance, to sekeeping, to open water, to planning regime, to matrix of simulation for thinning out foils and trim optimization. So it covers a very wide range of application. So it's very useful for beginners, of course, but also for experts. Even internally, even myself, I use the C Wizard daily because I don't want to spend time doing all the same things again and again. I want to speed up my process. I want to speed up my the way I'm working. And so I always rely on C Wizard to make at least the basic setup of my simulation. And if you don't have enough, I would say, confidence, or you always want to do something extra that C Wizard did not foresee, there is, of course, no problem. You can always change the setting afterwards, either by changing manually inside the interface or just by adding a script on top of it. So the C Wizard is not at all a black box. It's very important to remember that. We don't want to force you to use the setting that the C Wizard has created. It's just a default setup, which is very very good, I would say, and also totally standard for all the CFD simulation that we are proposing as application. And the second reason why this combination is also very important is because the cloud can be used for frequent work. So we have users which are asking that frequently all along the year, or just for users which have just a peak of work for suddenly, and then they have an unusual workload that they need to absorb that their machine cannot do at this present moment because the machine is already fully busy. So that's the message that we wanted to convey with this combination of the cloud and the C Wizard. So that's the end of my presentation. So if you have any question, I'm here to answer them, of course. So the way to ask the question is the following: you go to the question frame or the question box, and then you just type the question. I will read it loudly, and I will try to answer that for everybody. This presentation was recorded, so you will receive both the presentation and the video in approximately 2 days from now. Okay, I see that some questions are already coming in. The first one is for about the application, which is about the wave energy conversion test inside the C Wizard application. So I'm not 100% sure about what you mean, but if I understand what you will try to say here, wave energy conversion, you will mean, for instance, a device which is floating into the water and which is converting the wave energy into electricity or something like that, I would guess. So let's take that as an example. There is no problem. So the idea would be that you could use the Wizard as a sekeeping application. You will say that your ship or device has a 0 speed, and for us it means something. We are going to transform this information into special type of boundary conditions, special type of wave generation, because since it's a standing still object, there is no speed, so we can always have wave reflection that we need to dump and to avoid compared or when we are going towards the boundary condition. So that would be the one to use from the C Wizard application. There is another question about, is it possible to simulate the ice for a polar cruiser or ship-breaking ice, for instance? This is not possible for the moment. However, I don't know if you were present at our user meeting or if you have seen this kind of videos. We have started last year a collaboration with a company from Belgium, which is making what we call DEM models. So discrete element methods, in the sense that you can could combine in the future FineMarine together with this code. If you want, I can send you a first prototype that we have done last year, because it's quite impressive. We were seeing the DTMB full appending going, crossing the ice and breaking the ice during the simulation. So what we need to do now, and which is already started, is to make this version industrial and of course to propose it inside the packet. All right. So yeah, we got the question about the cost per CPU hour. This I think already answered. So it will depend on how much you want to book. If you start with a very low number of CPU hour, for instance, the first ID would be 0.99 euro per CPU hour. But as soon as you increase, then the price will decrease a lot as well. So we have seen that booking 4,000 CPU hours, we go already half of the price, 0.47 euro per CPU hour, and this will continue to decrease. So that's very important to understand that. So the number of processors which are available in total, I could say an infinite number. Well, okay, infinity does never exist in on the computer, but I think you will not be, you should not be worried about that, because we have thousands of cores just at NUMECA. We have 9,000 of cores just at NUMECA available. We have thousands of cores in CPU 24/7. We have thousands of cores at Vania, and I don't count all the other providers that we can also ask to help you on that. However, every machine or every node that you are going to book contains 24 cores. And then you will start by 24 cores, and you multiply this number by the number of nodes that you want to book. So there is no restriction on that. Also, you can always run, if you, for example, you book one node of 24 core, you can always say, I want to perform, because my simulations are very fast and very light, I can only book one node, and I can perform several simulations at the same time on the same node. There is no restriction on that. All right. Okay. Of course, the question are coming back to about how to estimate the time and so on. For instance, if you don't have the hard details, how many CPU hours are required? This is definitely the best question ever, because I get this question quite often. So, Benoit, can you tell me how many hours should I book if I'm going to run a sekeeping simulation, but I don't know yet which geometry I'm going to run? Yes, this is extremely difficult. So if someone has a magic rule, I would be very happy for that. But sadly, for the moment, I don't think it exists, because this cost estimation or the CPU hour estimation always depend on the geometry. What I can, however, provide to you is, for instance, if you have a bare hull, or if you have appendages, for instance, you have a shaft, a rudder, if you have build skills, if you have, I don't know, whatever particular structure, you can tell me. For me, it will mean something. It will say, okay, you have a rudder, so let's add 1 million cells on top of that. If you have build skill, etc., etc. But I will need estimation. I will need as many information as you can. For instance, the phone number is also very important. The type of wave is also very important, because if you are doing very short wave, it will not be the same as very long waves, etc., etc. If you are doing self-propulsion or not, or fixed speed. So all this information are very important, and then I will give you the best approximate I can. But of course, there is no magic on that. Next question about numerical ventilation at very high skilled angle in planning condition. Yes. So this is definitely the case for the high-speed boat application. So for us, I mentioned that for planning regime, we are doing something particular compared to the classic resistance simulation. So starting from 0.4, we know that the boats will be at high speed. The trim amplitude or the sinkage amplitude will be quite important. And for us, it means first that we need to make sure that the mesh deformation will not fail. That's one first issue to take care about. And for this, we are going to ask you to estimate as much as you can, the final position of the boat. That's one thing. As soon as you have done that, either through automatic method, either through experience, either through discussion with the support team, for instance. You set up this, and then we are going to apply particular simulation parameter for the simulation. For instance, ventilation is very important as well to take care about, because ventilation could be numerical effects or physical effects. Some of them are numerical because all the VUF methods that everybody is using for hydrodynamic simulation, the VUF method is something particular that they can provoke, or they can lead to numerical ventilation. It's somehow some air which is trapped inside the viscous layer zone, which are not physical and which need to be cured. So this is something that we, of course, will take care about during the simulation. We have some special treatments for this kind of phenomenon that we don't want at all. Another one is the physical ventilation. For physical ventilation, we need, of course, to preserve that, and we are going to take care about it because we know how to differentiate physical and numerical ventilation. And this correction or numerical intervention will be able to make the distinction between the two, and so propose or to preserve the physical one. And this is also very important, for instance, for surface piercing propeller, where the ventilation is very important and we need to preserve that. And it's the same for high-speed boats, so we need to differentiate that, and so we have dedicated parameters to comply with both. All right, so if you have any more questions, I don't see any for the moment. Okay, I give you, of course, a couple of seconds extra. Otherwise, I will close this session. But I hope that it was interesting for everybody. I hope it was clear enough. And if you have any question, of course, please contact us, because we know that that is very important to really know what's happening with the cloud and how you could propose that internally or to your customer. So do not hesitate to come back to us if you have any subject that you want to discuss. Okay, great. So I see many people which are saying that everything was clear, that they want to, some of them want to use it. So that's extremely interesting for us as a feedback. So thank you very much for this. If there is no more question, then I will stop there. I would like to thank all of you for being there. You were a lot of people who were attending this webinar. So thank you to all, and I wish you a very nice day. Bye-bye.